Alright, this is Lecture 5, Page 2, Function Composition. Now sometimes a function can be within a function. So here's what I have. I have f of x is equal to, in parentheses, 3x squared minus 2 raised to the 6th power. Let me rewrite this a different way real quick. I'm going to write this as h of x is equal to, I have on the outside something to the 6th power, and on the inside I have this other function, 3x squared minus 2. So I have two things going on. The part in red is my inside, and the part in the blue is the outside. So what I'm going to do is I'm going to let g of x equal to 3x squared minus 2, and I'm going to let f of x equal to x to the 6th. Right, I just replaced the whole inside with x. Now g of x typically is called the inner function because it's inside. And the f of x here is going to be the outer function. Now, here's what happens. Okay, let me show you. So then, to find h, what happens is first, the x gets sent to g, which is the inside function, 3x squared minus 6, and then we send that to f, which puts this on the inside of f. Remember what f does, that's something to the 6th. And that something in this case is whatever the inside is. So that's 3x squared minus 2. So the way we write this is that h of x is equal to f of 3x squared minus 6. But 3x squared minus 6, that was just g of x. So that's f of g of x. So notice this is the inside function and f is the outside function. You can also write, or f with brackets. Sometimes you'll see it that way. Okay, now definition. Given the functions f and g, the composition of f with g is written f composed with g. We define it this way. So we define it f composed with g of x is the same thing as saying f of g of x. Now the domain of this, you have to keep tabs of what's going on in each case. The domain is all of the x values of g. So it's all the x in the domain of g. So that now we have to have g of x as the domain of f. So that g of x is in the domain of f. Now we have a similar definition for g of f. So similarly, g of f of x says now the inside function in this case is f and the outside is g. So you can actually reverse f and g. So that's going to be g of f. And the domain of this guy, you just got to look at it. It's all the x in the domain of f with f of x in the domain of g. Now one thing I want to send out as a word of caution here is that caution, in general, I mean certain cases are certainly true, but in general, for the most functions you meet off the street, f of g of x is not the same as g of f of x, right? Because obviously the inside functions are different.